Now that we're down to just one unknown, the focal length, since distortion has already been solved, I'd like to try refining it a bit more. We go to Window, Adjustment window, and reset the previous value. I want to search from 1 to 8 and we'll see what comes out of it. Let's try 100 samples. Not sure, maybe that's too many, but let's go with it. Click Adjust. It still says the lens has a very short focal length. Let's trust it. Okay, it once again hit the left edge at 0.36. Looks like I did set the vignetting correctly. That's good. Let's reduce the number of samples and run it again, a bit further to the left. So we'll expand the range from 0.1 and let's say up to 5. And the best value is 0.36, going from higher to lower. And right here, somewhere around here, the value is 0.36. After that, as the values get smaller, the error immediately starts increasing. We can see the error point rising. So it turns out the minimum error is at a focal length of 0.36 millimeters. Okay, fair enough. Let's recalculate. But the wall really is straight. All right, we like that. Now I want to add a couple of trackers here and export what we've got into the compositing software. Let's check our stabilization track. That's something you should always do. For example, we select a point in lineup mode, center the view on the 3D point, and as we play through the shot, we keep an eye on it. And we can clearly see, this is, to put it mildly, far from ideal. Probably we'll see the same thing on this other point too. I actually noticed it earlier, and look how poorly it tracks. Where should you start when checking a track like this? First of all, we need to make sure that the 2D point isn't sitting the same way as the 3D point. If we center on the 2D point and hit play, we see that everything looks pretty stable. Where should you start when checking a track like this? First of all, you need to make sure that the 2D point doesn't sit the same way as the 3D point. If we disable the 3D points, we can see that the motion path is fairly stable. We're not taking the corners into account. Those are seriously distorted here. Alright, let's turn the 3D points back on and confirm that everything's jumping around wildly here. So, what can we do first? If all the trackers are actually decent, one thing that comes to mind is that the post filter might be smoothing the camera path too much, even though the tracker itself is fairly stable. Let's open the point group settings and try playing around with the smoothing options. We can try turning it off and recalculating the camera. Let's see what we get. So we center on the 3D point. Well, this already looks better. Not perfect. Again, we've got really distorted edges, but we can see there's no massive jitter anymore. And this is exactly one of those rare cases where smoothing works against the actual camera motion. Didn't expect we'd get to show this, but here it is. A moment where it actually came in handy. Glad we managed to demonstrate that. If we want to make the track more accurate in this area, we can simply increase the weight of that specific point. Right now, all trackers have the same weight, but we can tell the program this particular point needs to be as precise as possible. That means the 3D point will be forced to match the 2D tracker as closely as it can with minimal error. This is usually done when you're absolutely sure the track is spot on, and that point should serve as a reference. But keep in mind, if the point is still drifting slightly, maybe it's worth refining the track a bit more. Right now, if you look closely, you can see it does shift a little. Still, if we decide this point is critical and must be locked down, we just increase its weight. Let me go ahead and tweak the track out toward the edge a bit more and show you how that works. And I'll set the weight of this point to, let's say, 10. Let's recalculate the camera. Let's switch to lineup mode. Now you can see that the 3D point sits on the 2D tracker much more stably. We can pin it down with maximum precision by assigning it a huge weight. For example, if I set it to 1000, then recalculate the camera. That means it's completely locked to the point. The camera track adjusts itself to match this point at the expense of all the others. And that's exactly the problem. As soon as the tracker slips, you'll immediately notice a visible jump. See? We have a 3D point here. Imagine we want to place a sign. For example, to replace this label. Naturally, it will be built based on the corners of 4 trackers. So it's important that the corners of the plane will composite match these trackers precisely. What else can we do? We can define that these points lie on the same plane. That way, it'll be easier to place the sign in compositing. And we can also set this particular point to be at the origin. All coordinates as 0. For this point, we can specify that we know its exact position in space, that is, assign precise coordinates to it. This point's x coordinate remains unknown. Y is 0 since it's on the same level as the first point, and z is also 0 because it's at the same distance from the camera. For this point, we can set x to 0, leave y as unknown, and set z to 0 as well. For this point, we can say that we only know the z coordinate. Let's recalculate once again. Well, I guess with this result we can move on.